Limiting reactants practice problem number 5. We have potassium chloride plus sodium bromide producing potassium bromide and sodium chloride. I have already underlined the key terms for you, and I have balanced the equation. So how many grams of sodium chloride, so this is the product we're looking at, could I produce if I combine 12.1 grams of potassium chloride with 12.1 grams of sodium bromide? So first, of course, our equation is balanced, so now we have to convert our two reactants from grams of reactant into grams of product. So start off with 12.1 grams of KCl, and we are going to convert that into grams of sodium chloride because that is the product in this situation that we care about. So here we go, 12.1 grams of KCl. Now, the molar mass of KCl is 39 grams for K plus 35 for Cl. Whoops, 39 plus 35, not 39 multiplied by 35. So you end up with 74 grams. 74 grams KCl equals 1 mole. 1 mole KCl. So now we've converted to moles, and now we have to go to our equation and do our mole to mole ratio. Luckily for this equation, it's very easy because there's no coefficients in front of anything, so everything is just 1 mole. So 1 mole KCl is equal to 1 mole NaCl, and I'm getting that all from the equation. Remember, our third step on grams to grams is our mole to mole ratio from the equation. So I get those coefficients from the equation. Then we have to go from moles of NaCl, 1 mole NaCl. We have to go with moles of sodium chloride into grams of sodium chloride. So we have to go 23, which is the molar mass of sodium, plus 35, which is the molar mass of chlorine. We end up with 58 grams NaCl, just like that. And if you look at our dimensional analysis, we have crossed off each of these different items, and we have arrived at grams of product. So now we multiply straight across, so we would do 12.1 times 58, gives us 701.8, and then we divide that by 74, to get our answer of 9.48, so we're going to round that to 9.5. So 12.1 grams of KCl produces 9.5 grams of sodium chloride. Are we done? Absolutely not. We have to do another dimensional analysis, this time with grams of sodium bromide. So we have the same number of grams of sodium bromide, so 12.1 grams of sodium bromide. Set up our dimensional analysis. Set that up right there with our dimensional analysis. The molar mass of sodium bromide, bromine, is 80 grams per mole, plus sodium, which is 23, equals 103 grams per mole, grams of NaBr. 1 mole NaBr, sodium bromide. Now we have to go to our mole to mole ratio, which I get from the problem itself. They are all ones because there's no coefficients, so 1 mole sodium bromide is equal to 1 mole of sodium chloride. And then we end the same way we ended up there by going from 1 mole of sodium chloride to grams. So 1 mole NaCl to 58 grams. So we can cross off everything we've canceled out to arrive at grams of sodium chloride once again. And again, we multiply straight across, and you can probably already see where this is going in terms of 12.1 multiplied by 58, 701.8 again, but this time we're dividing by 103. So this is going to produce 6.8 grams of sodium chloride. 6.8 grams NaCl is how much this is going to produce. So our final step, we look at whichever one is lower, 6.8 or 9.5. Well, obviously 6.8 is lower, so that is going to be how much is actually produced. And our limiting reactant in this case is whatever produced the 6.8 grams, which would be our sodium bromide. So right there, sodium bromide is our limiting reactant, and 6.8 grams of sodium chloride are actually produced. Go back and watch these practice problems again if you're still struggling. Otherwise, good luck.